Hello, welcome to our latest webinar on restoration. So we're going to get into a little bit of how to do restoration, why it's important, and just making the most of BC's local ecosystems. So my name is Jamie and I'm here with my partner Alexa, and we're going to be taking you through a little bit about restoration today.
Okay, so before we begin, of course, we'd like to recognize the really diverse history of Esquimalt Gorge Park. So Esquimalt Gorge Park has had a really diverse history through time. So the park is actually part of the traditional and unceded territories of the Lekwungen-speaking peoples, today known as the Songhees and Esquimalt First Nations. So they, with other First Nations groups, such as the Suk and Saanich peoples, have deep historical and current relationships with the land that continue to this day. Prior to European settlement, the Lekwungen peoples used Gorge Waterway for fishing, hunting, and travel. So Gorge Waterway was referred to as Kemosak. And we have provided a link here, as well as an email reach out if you'd like to learn more about the Lekwungen speaking peoples.
So why do we want to do restoration? Why is it important? So the earth and nature are going to eventually reclaim what we've created, and given the space and time, the ecosystems would recover on their own without intervention. So why do we want to do it? It's basically, it just speeds up that process of environmental recovery. That timeline, without intervention, there's no way we could know of it. And it's often unrealistic to expect that an ecosystem would be able to remain untouched without any interference by humans, or any human impact for the amount of time that the ecosystem would need to truly recover. So with our restoration efforts, we can try and restore the environment in a faster timeline than without. One of the main things that we're trying to bring back to an ecosystem are ecosystem services. These are basically benefits that people get from ecosystems. So examples include carbon storage, climate maintenance, and controlling water flow. And a lot of our restoration occurs in urban areas because these are ecosystems that are most frequently impacted by human activity. Some of the ecosystem services provided by these urban natural areas include mitigating a bit of that urban heat island effect. It's where an urban area becomes a lot hotter because there's not as much heat dispersing elements to it. It also can lessen the load of urban drainage systems, improve air quality, and also has a significant impact on human mental and physical health. Another benefit of restoration is generally an increase in biodiversity, which can enable an ecosystem to become healthier and more resilient. If you increase the biodiversity of a site, it increases that resilience due to the interaction between the organisms. So each organism comes with its own capacity for dealing with stress. And if you do have this diverse composition, each organism is going to be able to contribute to overall ecosystem resilience.
Okay, so when we're deciding how to restore a site, there are obviously a lot of considerations to be had. Restoration is a very large topic. When we're looking at restoration, specifically here in BC, the BC government has actually separated both terrestrial and aquatic systems. It's made them separate. So when you're looking to do a large scale restoration project, you can actually see the priorities within each of these two systems. They're ranked amongst themselves. When you're also considering a restoration site, there are other considerations to be had, for example, land ownership, and we'll go through kind of more of an extensive list shortly here. What's interesting, when they grouped aquatic systems, they mentioned high priority watersheds and subwatersheds, but they did not include wetlands and lakes, lakes such as kettle lakes. So generally, this is because all wetlands are considered high risk and high potential for restoration activities. They're very integral. They provide us a lot of ecosystem services and have a high degree of biodiversity. Those kettle lakes that I just mentioned, they're often great sites for restoration because they're often impacted heavily by agriculture and other human effects, and they also hold high biodiversity. So in these terrestrial systems, the government categorized these sites into BEC zones. BEC basically is an acronym that stands for Biogeoclimatic Ecosystem Classification. BECs are basically a way to categorize different ecosystem types based on their vegetation, their climate, soil, geology, and also their placement on a successional scale. Successional scale essentially meaning how far along the ecosystem is from a very basic level. So at your more basic successional stages, you're going to have younger, more simple ecosystem assemblages, whether or rather as you go higher up into the successional scale, you're going to have a little bit more resilience, a little bit more complexity, some longer lived species. Understanding what BEC zone you're in can help you understand your ideal outcome for a restoration project. For example, in the EGP, we are within the coastal Douglas fir BEC zone. This is categorized by large population of those Douglas fir trees. We also have mild wet winters and relatively dry summers. In your info pack, if you do live here in BC, you can actually check what BEC zone you are in, which is quite interesting.
So once you've established your desired future condition, now you're really starting to plan this project. So outlined by Hobbs and Norton in 96 is your kind of the main procedures you want to follow. So step one, you want to figure out why the ecosystem is or has been degraded. If you can't figure out why that ecosystem is being degraded, it's probably going to be difficult to determine an effective way to either limit or improve that situation. Number two, you want to define a restoration goal that's achievable based on that desired outcome. So determine whether that goal is, lessening the extent of future degradation, maybe eliminating future degradation, or even just enhancing or restoring the ecosystem. Number three, you want to develop that prescription to achieve those goals that's specific to your problem and ecosystem. So based on what you determine to be the problem and the classifications of your ecosystem, what steps are reasonable and achievable to improve the situation? Number four, you want to identify key monitorable aspects of the project and how to measure those changes. So this is how you're going to measure success. For your small scale projects, maybe you're just going to use something as simple as like a visual cue. There might be less English ivy, and that's your measurement. Number five, you're going to implement it. So that procedure you put in place, go do it. Number six, you're going to monitor your progress. So using those same monitorable aspects that you outlined prior to implementing that procedure, you want to compare to your baseline measurements. And then number seven is usually just maintaining that progress. So it's unlikely to be a one and done procedure. A project requires maintenance, and often the reasons for the system degradation are still present in some amount. And it's going to require continued monitoring and further restorative actions in order to maintain your initial efforts.
So as we've mentioned, in order to really have your clear success, you do have to have these goals and objectives quite well thought out prior to even completing your restoration project. So these can be simple. They don't have to be as complex as we see in large scale restoration projects. This chart is quite complex. So you can see that there's a large goal and there are several objectives to accomplish this goal. But it can be simple. It can be something as simple as I want less invasive species in my yard to create a more resilient ecosystem. And your objectives could just be to perform invasive species removal and planting native species, for example, at certain intervals or certain times to accomplish your goal. So this can be, this framework can be applied to small scale personal restoration too.
We've also got a lot going on in our new pollinator meadow. So this was put in at the end of last summer, planted with a bunch of native species, trying to bring in just more native pollinators. So we're going to see what our restoration crew is up to in there.
Okay, so this is our restorationist Grinch. He's going to be talking about restoration and biodiversity in the meadow.
In the meadow here, so yeah, we're just pulling the grasses and things from there.
Awesome.
It's important because getting rid of invasive species can help native species grow, and that increases biodiversity, especially insect biodiversity, which can help bird biodiversity, like purple martins, for example. So yeah, it's all just important to basically the general idea is increasing biodiversity.
Going deep in, and then I'm trying to just loosen the soil up a bit, like the roots, until I can actually get a firm grip on it, and then I pull it out.
Awesome.
Yeah. But yeah, it's very, very, you gotta be very careful, because like obviously the root system is near the other plant, but yeah, just being really careful. also hard because all the snow, the soil is a lot more compacted and saturated.
So how do we gauge success? There's something called indicators that restorationists like to use. An indicator is a monitoring metric, not to be confused with indicator species, which is kind of a different topic. An indicator can be something that relates to your goals and objectives and will help you determine restoration success if used properly. They're often called ecological or ecosystem attributes, and they can direct scientists towards information about the environment. Again, you want to be quite specific and tailored to your own local ecosystem. An example of an indicator could be organic soil content or species richness. Even with these indicators, we do have a lot of uncertainty with how effective restoration projects might be, and what makes them success or failure can still be vague, no matter how informed we go into the project. And it is quite difficult to gauge success or failure, especially within a short time frame. Failure is arguably easier to describe, and it can occur when a restoration project has a poor idea of ecology, poor described objectives, unforeseen problems, no gathering of data post restoration, no supervision. The list goes on. Sometimes, even if you do everything right, even if you do look at your ecology, you do follow up with your data, things can go wrong, and sometimes problems come up, and restoration projects do unfortunately fail. So failure can be confounding too. Projects might work for some time, they might deteriorate later. The only way to find out if a project is going to be successful, obviously coming in with thorough research too, but is just to implement it. And then you can see.
Yeah, so as Alexa's saying, monitoring's an important factor to determine the effectiveness of your protocol and determine your next steps in your maintenance too. So if you monitor your project closely, you're usually going to learn new insights about that ecosystem you didn't know before. So you might learn what you initially implemented as your plan might not have been the best method for that system in particular. So we often don't know as much about a stagnant ecosystem as we can about one that's responding to change. So the way that system responds to the change usually informs you a bit more. Good quality monitoring can also allow you to change your goals for your future projects so that they better suit either that system or another one. And the measuring of that success depends on that goal. So if you wanted to improve habitat for maybe a threatened or endangered species, monitoring the population of that species in the area might be a good effectiveness gauge. You know, for a lot of projects that might be smaller and simpler, effectiveness monitoring might just look like, did my removal of this invasive species contribute to its lowered prevalence in that area, whether that's short-term or long-term? A widely accepted notion for success is when the resource system very closely resembles a similar and naturally regenerating system in terms of structure, function, and resilience, or when the compliance of the project goals are reached. So generally, an assessment of a restoration will include looking at the ecosystem's function and structure, as well as connections between the restoration's actions and the response in the environment.